Hello, everyone.
Hello.
Yeah. So in today's class, we will quickly finish looking at merge sort, and then we'll move on to the discussion of UMLs and how to design different design elements in code. So before I get started with merge sort, any questions from last week? Any questions that students have? Any questions? Okay. So merge sort is also a divide and conquer technique, just like your quicksort algorithm. Now assume that an array A has n integers and this is the input that has been given to you. Yeah, Venant, please go ahead. Venant, go ahead, ask your question. Oops, I think he's not been able to ask. Samuel, you can go ahead.
Thank you, Professor.
Yeah.
Yeah, from the mail that I received from in my inbox concerning the plagiarism policy, I can remember you mentioned that at some point, probably maybe we can borrow some concepts from the starter code or from the example code you gave in class. So in a situation whereby we have students trying to borrow some of the codes that we use in the class example, and it's kind of similar during the check. So does it still apply to the same plagiarism policy too?
So I did. So the way it worked out with the plagiarism part is we went through your code line by line. So every student whose code was flagged by grade scope, we actually went through it line by line. Okay. And when we saw that there is a significant overlap beyond what has been given in class, beyond the sample code that has been given in class and so on, that is when we conclude that the students have plagiarized. Does that clear your doubt, Samuel?
Yes, Professor, thank you.
Yeah. Venant, go ahead, please.
Thank you, Professor. I'm sorry for my internet. My question is about the word forming assignment with rest time. Also, my concern is about the time complexity on the recursion function. So how can we analyze the time complexity on a recursive function as that one get valid words with max score, as we don't know the length of the dictionary and the length of each random string. Thank you so much.
Yeah, I couldn't hear your question very clearly.
My question is how to analyze the time complexity for a recursive function.
Yeah, so we will cover that in the next class. So unfortunately, you'll have to wait till that happens. So you are saying that you have implemented a recursive function and you need to understand what is the time complexity of it.
Yes, yeah.
Right. So we'll have to wait till we get to that class. Yeah, so we'll have to just wait till we get to that class. But I can tell you one thing, like in the assignments, we are measuring your runtime complexity in the number of seconds that your code takes to run. So you really don't have to do any computational complexity analysis, any formal computational complexity analysis. So you just have to make sure that you're trying to implement the fastest technique that is possible in terms of something that is efficient and runs very quickly. Now, a formal analysis would help, but even without a formal analysis, you should be able to understand how much time your code is taking to run. That we have already given you. Now, using that, you can change certain parameters of your code to make it run faster. You can implement a slightly different technique that runs a little faster and then measure the time difference in seconds. So that will help you. But the formal analysis itself, we are going to wait till a couple of weeks pass. And that is when we will learn how to do a formal analysis. Honor, please go ahead.
Thank you, Professor. My question is somehow similar to Samuel's question. I would like to know about the announcement which you shared with us. I would like to know about sometime in the assignment, we found some data structures have the same process or same way that we can implement it. So will that be considered like plagiarism? Or so I have a little confusion about that. There are some data structure which have the same way to be implemented. So will that be seen as the plagiarism? Thank you.
See, Honor, this is how we look at it, right? It's not just one or two data structures. There are students whose code is like completely the same as one another. Okay, there is like no doubt that these are copied codes, because line number 1 is exactly the line number 1 of the other student. Line number 2 is exactly the line number 2 of another student. Line number 3 is exactly line number 3, and so on and so forth. Okay, maybe they have changed some variable names and so on. But the logic and the program flow is completely the same. Now, you can define data structures. Yes, you're right. Some data structures may be similar, but at least like, there must be some difference in line numbers. Or some students might have written a data structure or defined a data structure at a different part of their program, or a different part of a different program, and so on and so forth. But if completely everything is the same, then you're pretty much copying from one another. So Venant, just to clarify, Venant is saying you have already been given some pseudocode to use. How is the similarity in this case checked? So the way the similarity is checked is the code that we have already given to you, that code is not included in the check. So we have an algorithm that automatically figures out, or rather to which we give as input, this line to this line is, or this function is a function that is given by the, that is already given to the students. So please ignore this. So we can give like template source code to the algorithm that does the comparison. And when we give the template code, we actually give all of the code that we've already given you. Now, when we do that, the algorithm automatically ignores all of that code and uses the remaining code to compute similarity. And after the code has computed similarity, myself and the TAs, we will go through every student's code line by line. And then we check if there is any similarity. So it's not like we completely trust the code, and based on that, we are deciding. Okay, or rather the similarity. We use that score only to give us a certain list of files that we can check. And only when we find that based on our manual check, that these 2 students or these 3 students or these 20 students have very similar code, at that time we penalize the students. Okay. My general suggestion is, do not show your code to each other. The moment, let us say, for example, student A and B, they are doing the assignment together. They decided that, okay, today we will sit down and do the assignment. Now, if A and B are looking at each other's screens while doing the assignment, then it is very much possible that if A writes a couple of lines, then B will write the same lines of code. And that's very dangerous. And in fact, that's not what you're supposed to do in this assignment. You are not supposed to sit together and write code. One student is not supposed to see another student's code. The moment someone sees somebody else's code, they will be tempted to write each code line by line in the same way. You do not even have to email your code to somebody else. They just take a look at it. It's just human nature. They will be able to write the code in a similar fashion. Subconsciously, they will start writing it like that. Okay. So let's get into merge sort. Merge sort divides the array into two parts, just like quick sort. The way it would work is the merge sort function is having the following entry point: merge sort A start index end index. And if the start index is less than end index, then you get into these four steps: step A, B, C, and D. Now, in order to sort an array, the function is called in the following manner: merge sort A 0, comma n minus 1. So the initial index, the initial value of start index will be 0. Initial value of end index will be n minus 1. And what happens when this is called as initially the partition index becomes floor of start index plus end index divided by 2. That means the exact center of the array is selected. And merge sort is called on the first part of the array. Merge sort is called on the second part of the array. And then there is a merge which is called. Okay. Dan is asking, what if the deadline reaches before one completes the assignment and requests for an extension to avoid plagiarism? Would there be some flexibility? Can someone answer this question? Can someone in the class answer this question? For 1 bonus point. Better give the right answer. Yeah, Venant, go ahead, please.
Thank you so much, Professor. I think it will depend on the professor's understanding. If the assignment is too hard, maybe professor can give extension. Just it will depend on the professor's understanding. Thank you so much.
That's not the right answer. What about the next candidate? Pax was the next candidate, I think, who raised his hand. Pax.
Professor, what I think is in the preparation of the assignment, we're given time that is considered enough for us to do the assignment. So I think in whatever case that one needs extension, it's better to say it way ahead before the deadline, so that we students will have to submit the assignment on time in whatever case.
Yeah, so that is the right answer. So Pax has given the right answer. So Dan, there is not going to be any flexibility. The assignment has already been published since the beginning of the semester. Everybody knows what are the deadlines. There are certain exceptions for giving extensions, and these have already been mentioned online. Canvas already gives you a list of conditions under which I'm willing to give an extension. And, not being able to do it in time is not a valid request. I mean, just because the assignment is difficult or you don't have time and you go ahead and plagiarize, that is not going to work out. I mean, think about it. If you're working in some company and they ask you to write some code, you just copy the code from somewhere or get somebody else to do the code for you. They are not going to be happy with you. So it's the same deal here. Just in order to meet a deadline, if you want to plagiarize, that's very difficult. But yes, like Clement is saying, it depends on the entire class. So Pax get 1 bonus points, and actually Clement also gets a bonus point. So Pax and Clement, both of you, 1 point each. Okay. Just for shedding some light. It depends on the whole class. So if, I get a feedback from the TAs, or I get enough number of students saying that, we need a particular extension because of some common problem that has occurred throughout the class, then maybe there could be an extension for the entire class. But, it has to be fairly a good reason. You cannot just say, hey, we are just finding it very difficult. Can you please give us an extension? That is not going to work. Okay. No, these reasons, specific reasons of a student, they are already posted on Canvas. You should be knowledgeable enough to read all that. This information is already on Canvas. Please talk to your TAs to understand what these requirements are and what are the conditions under which you can get extensions. Okay, let's get back to Merge-sort. Now I'm not going to take any more questions on plagiarism or assignment extensions. We have already discussed this sufficiently. Okay, if there are going to be any questions, let these questions be on Merge-sort. No out of topic questions anymore, or questions about any other assignments. Okay, from now on, if you have any question, that question should be about Merge-sort. All right, or quicksort, or the topic on hand. Now, Merge-sort is dividing the array into 2 parts, and that divided array, each part of the array is sorted. Each divided array is sorted, and then you merge the array. Okay. Now let's look at how it would function in the case of a particular sample data set to understand how this code works. Okay. So if this is your input data, which is the array 6, 11, 7, 8, and 12, when you first make a function call to merge sort, this is how the call goes out. So the first call So the first call to merge sort will be done like this. So the number of elements here is 5. So the first call to merge sort will be in this fashion. Merge sort A0, 4, merge sort of A0, 4. So the partition index will become okay, and this value resolves to be 2. Okay. Now, when you get this value, Okay, when this is the value that is obtained, what happens in merge sort is there is going to be a split of this array at this particular index. Okay, why there is going to be a split? There's going to be a split because you're going to make a call to these two functions. Okay, now a call to these two functions would do the following. So because of this, there is going to be a call to two functions. Okay, this is going to be the call. Now, when these are called, merge sort 3, 4 is making a call to this. And merge sort 0, 2 is making a call to this array. Now, when merge sort 0, 2 is called, merge sort 0, 2 is called, the following will be happening. For this, the partition index, which is computed as 0 plus 2 divided by 2, which is equal to 1. Here, the partition index will be, so I forgot to write floor here. Okay. Floor of, and here the value will be 3 plus 4 divided by 2, which is equal to 3. Okay. Now, when these two functions are called, this array, this particular array gets divided at the point 1. Point 1 is this. So you get these two arrays. Okay. This array is getting divided at partition index equal to 3. So you get these two arrays. Now these arrays cannot be divided further. 8 and 12, you can't divide them further. That's where the merge sort algorithm will stop. This particular iteration will stop this code. See these two lines are what are dividing the arrays into different parts. But the moment you get into this particular situation where there is only one element in the array, no further division is possible. So there is no recursion. These functions do not get called anymore. Okay, and at that stage, merge starts getting called. Okay, and let's see what happens when merge is getting called. Okay, so here what happens is this particular function leads to calling of merge sort of 0, 1, and this leads to calling of excuse me, this part leads to the calling of these two functions. Three, 3 and 3, 4. Okay. Now, when these two are called, okay, the second one, sorry, this becomes 2, 4. This also becomes 4, 4. This one and this one. This one and these two. There is not going to be any further split in these two arrays. This array, there'll be a further split. So this one, zero comma 1 evaluates to the following. So this gives you 0 comma 0, 1 comma 1. Okay, there is further, after this point, there is no further split again. Okay, so these two lines, there is no split. These lines, there is no split. The ones which I have highlighted in yellow color, there is no further split. But the ones that are not highlighted, there is a split in those cases. Okay, so let me write these also. Here, this will lead to the evaluation of merge sort 0 comma 2, and this will lead to calling merge sort of 3 comma 4. Okay, is this clear to everyone? Is this clear how merge sort is calling different different values based on end index and start index? So the initial value of end index and start index is this. Start index is 0, end index is 4. Based on that, you get these two values. Based on the first one, 0 comma, this is this one, 3 comma 4 is 3 comma 4 is this one. Okay. Now 0 comma 1 is this one right here. Okay. Clear? Now what happens after the merge sort is returning? After merge sort is returning, you are supposed to merge the arrays. And let us see how merging of the arrays works. Let's see this. The very first merge that actually returns in our case is this one. Okay, where merge of start index. So here you'll have after these lines are over, here you'll have merge of 3 comma 4. Similarly, here you'll have merge of 0 comma 2. Okay, so and here you'll have merge of 0 comma 1. So let's see how this merge function actually works, how the merge function goes about doing its thing. Okay, so what is the merge function doing? The merge function is, so before we get into that, see, these are all the partition indexes which I've highlighted, and these are the arrays that have been obtained. Now what the merge function does is it starts merging the arrays one after the other. So the arrays that are merged are these ones, the last ones. 6 is merged with 11. 7 is merged with these two elements. 8 and 12 are merged. Then this array is merged with this array. Okay, and let's see how the merging happens. So these are the inputs. These arrays are the initial inputs to the merge routine. And what is the merge routine going to do? This is what the merge routine is going to do. Let's consider these two, 6 comma 11. Okay, when this particular function is called, right, merge a of 0 comma 0 comma 1, when this particular function is called, This is how it works out. You get into this function merge, start index, partition index, end index. Okay. So sorry, all of these would also have to contain the partition index. So here you'll have 1. Here you'll have 3, 4. Here you would have 0, 1. So what we are discussing in the slide deck is this one. The slide number 36. Okay. Yeah, Daniel, Emmanuel has already answered your question. Partition index equal to floor of start index plus end index divided by 2. And for giving this answer, Emmanuel will get 1 bonus point. Emmanuel, you're getting 1 bonus point for having answered Daniel's question. Okay. Now, slide number 36 is discussing merge of 0, 0, 1. So how does this work? So this value is 0, this value is 0, this value is 1. Okay. So length of array 1 evaluates to the following: 0 minus 0. So partition index was 0, start index was 0, plus 1, which is equal to 1. Length of array 2 is end index minus partition index. So end index is 1, partition index is 0, so this becomes 1. And then you are creating array 1 of this size, you're creating array 2 of this size. So you create array 1 of size 2, create array 2 of size 2. Okay, because the size is 1 plus length of array 1 and the size of 2 is 1 plus length of array 2. Therefore, both these arrays are created. And then you're copying a 0, 0 into array 1. See, you're doing this step. Copy a start index, partition index into array 1. Copy a partition index plus 1, end index into array 2. So that's what is happening in these two lines. All right. And then you are saying array 1 is equal to array 2 of length, which is equal to infinity. So the last element in the arrays is made equal to infinity. So that's what is done here. The last element is made equal to infinity. Okay. Then you define I, j equal to 0. Two temporary variables are defined. And then you have a for loop that goes through the second array. That is going through the second half of the array. Okay. And what is it doing is, so it is saying partition index to end index. So in our example, it will be saying 0 to 1. Okay. If array 1 of I is greater than or equal to array 2 of j, then you do an exchange. Okay, and you make a of I equal to I plus 1. So essentially what you're doing is you're trying to find out if there is any element in array 1 which is greater than element in array 2, and if that is so, copy that element into the original array and then increment this counter I is equal to I plus 1. What do you mean? Where does that infinity come from? So you can store a very large value. So you can store something like int max instead of infinity. Obviously, infinity doesn't exist as a normal variable in C++, but you can store int max. Is that clear, Venant? Okay. Now in the same way, you put a of k equal to array 2 if this is not true and increment j. So what you're doing is you're altering elements in the original array based on which elements in array 1 and array 2 are greater or smaller. So by going through this for loop, what ends up happening is these elements get adjusted. So they will come in the correct order. So this will get turned into 11 and 6. Okay. Now, what will happen is if you run it on these two, right? 8, 12. If your call becomes merge 3, 3, 3, this will return in the array becoming 12, 8. Okay. And 6, see this 11, 6 and 7, when it is merged, 11 and 6, when it is merged with 7, at that time you'll have 11, 6 and 7, which will be merged to become 11, 7 and 6. And then finally, you'll have merge of 0, 2, 4, where this array 11, 7 and 6 will become merged with 12, 8 to give you 12, 11, 8, 7 and 6. And that's the final answer that you get. Okay. So this is the final result from merge sort. Clear to everyone? Any questions so far? So merge sort and quick sort, these two are in general the most popular sorting algorithms. Okay. You do have bubble sort and insertion sort. Yeah. The complexity of merge sort, time complexity of merge sort is n log n. So in order to have this if condition being satisfied, so Victor, this if condition will prevent you from running over the end of the array. Okay. If one half of the array is shorter than the other half, then by putting a plus infinity at the end or int max at the end, you prevent from overrunning that array. Okay. Now we'll change the topic and move to a different subject. So we are going to move to algorithm design. And in this topic, we'll be discussing pseudo-code, flowcharts, finite state machines, and unified modeling language. Okay. This is a reasonably easy topic to understand. So we'll probably going to very quickly be able to go through it. Okay. And most of you might actually be very familiar with this. So if you think I'm going a little bit fast, let me know and I'll go a little slower, but I think we'll be able to finish this topic in like 20 minutes or so. We won't really need a lot of time on this. Okay. Maybe we'll take a little bit more time on finite state machines, but all the other topics we should be able to go through it very quickly. So a few definitions. What is meant by an application or a real life problem? An application or a real life problem is a description of a computational objective. Generally, when we say objective, it is usually a computational objective or an industrial processing objective that needs to be achieved. In the case of computer science, it is achieved by processing data. But in the case of other domains like industrial engineering, chemical engineering, or let's say the polymer domain, you may process different things. The objective might be, for example, in the pharmaceutical domain, the objective would be to generate a certain medicine, and the processing elements would be certain chemicals that are given as input. So given an input as certain chemicals, how do you obtain a particular medicine? So that could be the real life problem in the case of pharmaceutical companies. There could be a different process where, for example, let's say you're a company that is manufacturing oil, petroleum oil, which is doing fracking of oil, fractional distillation of oil. Fracking is different. So if there is a company that is doing fractional distillation of oil, then this objective would become, how do you generate petrol, kerosene, diesel, jet fuel, and various other kinds of fuels from crude oil? Okay, so the objective will be, how do you generate different types of refined petroleum products? Okay, so refined petroleum products would mean your petrol, diesel, the fuel that goes into the jet engine, and so on, given that you're processing as input certain crude oil and maybe some more chemicals. So any real life problem can be given as that description. Okay, in our case, the input is typically data, and the objective is some modification of that data or some processing of that data or a decision to be taken on that data. Okay, when we say instance is a replication of a particular problem using a specific data set. So here oops. So your application could be sorting. Okay, so this is your real life application. Given an array of elements, so this is your input. The input is an array of elements. The output that is expected is the array in increasing order. That is the objective. Okay, instance example of input array. So one example could be, okay, this could be one example. This could be another example. Okay, and so on. So instances are examples. Okay, and the algorithm so the algorithm more formally is a well-defined logic that processes this data in a finite amount of time. So the most important things are, it has to be well-defined. You need to know exactly what are the steps. It has to process this data in a finite amount of time. So it has to process this in a fixed amount of time. That amount of time could be more, it could be less, it could be exponential, it could be whatever, but it has to terminate in a certain amount of time. And it has to meet the objective correctly. Okay. Usually you should be able to say how much time it will take to run. Okay. There are cases where you might not be able to say that, and we will discuss that. Those will be called non-deterministic algorithms. There are algorithms where you cannot tell how much time this is going to take and when it will converge. Okay. And we'll come to that and we'll discuss those. Okay. Implementation is a program or a code that can run on a computing device. Okay. And it should be able to take the instance and give you the objective. Tests, these are set of instances which will check whether an implementation is meeting the objective or not. So therefore, you'll see terms like test coverage. In the industry, you'll see questions of test coverage. Do you have sufficient, or sometimes it is also called code coverage. Okay. Do your tests have sufficient code coverage? Okay. What this means is okay. 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 So if this is true, if there are lines of code that will never be called, even if you go through all your test cases, that means your test cases do not have code coverage. They are not checking all aspects of the algorithm. So you need to have test cases that cover all aspects of the algorithm. Okay. So for example, in the case of sorting algorithm, what should be the test cases? Any thoughts? In the case of a sorting algorithm, what should be the test cases? What kind of corner cases should the test cases cover? Anybody? Yeah, Patrick, please go ahead.
An empty array.
Okay, empty array is one. Okay. Next. Okay, small array is another. Already sorted array. Okay. Small or big array. Well, Shemza, that kind of depends. Array with letters, you may or may not consider that to be a test case. If your code is not supposed to handle array with alphabets, right? Then you will not consider array with alphabets to be part of your test case. If your algorithm is supposed to handle it, only then will you consider that to be valid input. Otherwise, valid test case. Otherwise, it's not a valid test case. Arrays containing repeated numbers. Next. Any others? Array with only one value. Partially filled array. Okay. Again, this is valid only if your algorithm is supposed to handle it. If your algorithm is not supposed to handle null values, then you'll not consider this. Yeah, well, our friend Venant was not very specific. Therefore, this is not usually. Yeah, so here I was actually going to add a comment. Very good observation, Evelyn. So what is meant by big and small? So that was not very clear by Venant. So what do you mean by small array and big array? Right? If you have a million numbers, is that big? What about 1 trillion numbers? So what is big? So unless and until that is clear, okay. So there could be another thing. So I think with pretty much from here to here, we've covered all the cases. Okay. So normally these should be sufficient. Normally these should be sufficient. Whatever I've highlighted here, right? These should be more than enough, test coverages. So if you have all of these test cases while doing your testing, or while creating examples to test your code, then you would have properly, then you can assume that you have properly tested your code. The underlying data structure is often very important to algorithm design. So can you design insertion sort for integers if the numbers are stored in a singly linked list? What is the answer to this? 2 bonus points. Can you do insertion sort if the numbers are stored in a singly linked list? This is a question for 2 bonus points. Honor, please go ahead. No answers in the chat window. I would prefer if people do not give answers in the chat window for this. Honor, please go ahead.
Thank you. For me, I can say that in case we have sorted the numbers, we can insert, we can apply the insertion, apply the insertion sort.
No, did I mention anywhere in this that the numbers are sorted? I only said it is a singly linked list.
Here they are saying if the number are sorted in a single linked list, so
no,
I can
it
say
says
that
numbers are stored.
Are stored.
See,
Okay.
what is saying it is saying it is stored in a single linked list.
Yeah, I can say that it can be applied. The insertion sort can be applied.
Yeah, no answers in the chat window, please. Okay, let's move on to the next student. Nafiu, please go ahead.
I think you can use a single linked list for insertion sort, provided the linked list is sorted. But if it's not sorted, you can't use it.
See, if the linked list is already sorted, why should you do insertion sort? Yeah, if the linked list is already sorted, right?
Okay,
then why would you want to do
use it?
Well, I don't think you know the right reason for the answer, but let me look at Anu's answer.
So
Anu,
you
please
can't
go ahead.
use it because you wouldn't know whether it is sorted or not. And for insertion sort, you have to know the order in which the elements come.
No, that's not the right answer. Anu, let's take your answer.
I was going to say yes, we could use it. We would just have an extra, what's called now, an extra node, which we would use as our temporary variable in this case.
What would you use as a temporary variable?
A node.
Okay.
Like a node that is not connected in the what's it called now, in the linked list.
The node that is not connected in the linked list. I don't understand that. But your answer is a yes.
Yes.
Okay. Okay, so I think, see, think about how linked lists work, right? They have one element connected to another element in this fashion. And think about how sorting works. How does insertion sort work? Oops. Okay. You have to loop through all of these elements and you have to change the element based on whether it is present or not. Okay. You have to be able to loop through the element. So you need to have this for I is equal to n minus 1 to index plus 1. Okay. You need to know what is the next element. Okay. What is the next element after the previous element? You need to know that continuously. Now, in order to be able to do that, in order to traverse through these two for loops, will take a lot of time in the case of a linked list. Because every time you want to go through this for loop, right, you will have to go through all the elements and get to the n minus 1th element. So, sorry, yeah, this is bubble sort. Yeah. Okay. So if you want to execute this for loop, right, and then this particular while loop, you would have to go through each of the elements in sequence in order to access this particular element a of I or a of I plus 1. So the answer is technically yes, you can implement an insertion sort even if the array is in linked list. Because if you want to address a particular element, if you want to access a particular element, you can go through every element in sequence, access that element and get its value out. But in practice, if you try to do this, if you try to access elements, right, random access to any element in linked list takes order of n. So we discussed the amount of time that it takes to access a particular value. To access a particular value is order of n. So if you want to access the nth element of a linked list, you have to go through all the elements which are from 0 to n minus 1, and then you get to the nth element. So yes, you can implement this particular for loop and this particular while loop using a linked list. But in reality, it's going to be very expensive. So in theory, it is possible, but in practice, it will take a long time. Okay. Is that clear to everyone? An insertion sort or sorting algorithms in general will require you to have access to every element of the array. So you'll need to access a of index, you'll need to access a of I plus 1, a of I, and so on. And then some of the elements will have to be swept. When you want these random accesses, right? So you'll have to start accessing all the elements of the array. You can do this using linked lists, but it will be very, very expensive. So in practice, it is not used. Okay. Now, if you need to sort 10 million integers, is array the best representation? Yeah, Honor, please go ahead.
Yeah, I understand that in this situation it can cost a lot, but I would like to know whether is there any situation which we can find ourselves want to use this insertion sort as the only alternative to apply the sorting, or simply it is avoided to be used in this singular linked list. Thank you.
No, you cannot mix up singly linked list and sorting. You just have to avoid them. It's not going to work. The only exception, and there is only one situation where I would do an exception, is if you have something called sparse arrays. Okay. Let us say you need to sort 10 million numbers. So let us say you have a situation where okay, here what I will rely on is tree data structures. Okay. And I mean, the reason why I would do this is reason likely to have duplicates. It is likely to be very sparse. Sparse means that there are very few values. Lot of numbers are going to get repeated. If you have an array with 10 million integers, that particular array is likely to have a lot of duplicates. It is likely to be very sparse. Hence, a tree data structure is much better than an array representation. Okay. Other aspects, remember that formally an algorithm should end in a specific amount of time. Esther, your first question is wrong. It does not mean that the singly linked list is always sorted. Now, what are the ways of sorting a singly linked list? You can apply any of the techniques. But the problem is sorting of a linked list takes a lot of time. It does not mean that a singly linked list is already sorted. Okay. So what would you prefer? Will you prefer an algorithm that sorts 1 million integers in 1 hour or an algorithm that sorts 1 million integers in 1 minute? Obviously, we will prefer this. Okay. An implementation should be able to run on the hardware that the problem needs it to run on. So an implementation that is using 4 GB of RAM, is that better or something that uses 0.2 GB of RAM? Obviously, something that uses 0.2 GB of RAM is better, right? And the amount of algorithm that is used, the amount of memory that is used also depends on the algorithms that are designed. There are state dependent and stateless algorithms, and we will discuss these when we will get to HMMs, and that will be much more clear at that particular point of time. Okay. And we will again come back to this stateless and state driven algorithms. Essentially, stateless system says that you start the algorithm and you end the algorithm. There are a set of steps that you have to take, and the series of steps that you take will not change. Okay. Whereas if you have other steps in between, and in those cases, it may not be very clear which of these steps you have to take. And we will discuss these kinds of algorithms. Okay, Pax, we'll discuss this question after the break. What I'll suggest is let's take a break of 5 minutes now. We will take a break of 5 minutes. Some of you can think of the answer to question given by Pax. And when we come back, we'll discuss that question and there might be some bonus points if people can answer that question. Okay. And we are now taking a break of 5 minutes. Please come back in 5 minutes. Okay, we are done with 5 minutes. Let's all come back to the class. Okay. And let's get into pseudocode. Okay, by the way, we were going to discuss Pax's question. What do you mean by duplicates and how do they affect the array of 10 million values? Can someone answer this? Ayan, please go ahead.
If we have an array of 10 million values, then it's very likely that we'll have some numbers that are repeated within the array. So instead of sorting through all the entries in the array, you could try and group the numbers that are repeated. And then once you sort in the places you have repeated indexes, you just add them onto your sorting to reduce the complexity.
Yeah, so that's a valid answer and you get 2 bonus points. In fact, that's the reason why we had this assignment, the duplicate integer assignment. In a different version of this assignment, we have a unique integer assignment. So if you know that you're going to have 10 million input values, let us say you define an array containing 10 million integers. Let us say you define array with 10 million values. How much memory is going to take? Can someone quickly calculate? Yeah, Eric, please go ahead.
40 million bytes.
Yeah, so this will be into 4, which is equal to 40 million bytes. Can someone convert this? So this is approximately, which is approximately 40 MB. Okay. Now, instead of doing this, if I create a Boolean array of, so what is the value of int max So what is the value of int min and int max? So this is the value of int max. Oops. So the value of int max is this. I think it's around 200 million. Okay. Right. And int min is negative of the same thing. Okay. It just has one additional value at the end. Okay. Now this range is how much? If you take this range, if you add them all up, yeah, Sion, you should find that out. How do you get 21474836? Yeah, please find that out. That's a task for you. It's related to the largest number that can be stored in 4 bytes. The largest number that can be stored in 4 bytes is approximately equal to that. The largest number divided by 2 actually. Now, if you create a array of bits for this particular range, for this entire range. So int min is this. Oops. Int min is this. Int max is this, right? So if you create an array of bits having length equal to this, how much space will this take? Can someone compute this? If you create an array of bits having this length, how much space will be used? It's very easy. You should be able to do this quite easily. No answers. The answer is approximately this. Okay. And this is no, ignore the +1 for now. Ignore the +1. There is no need to have the +1. Okay. How many bytes is this? This is about 4 GB. Okay. Is this clear? This is approximately 4 GB. Now, if you need to sort 10 million values, you need 40 MB. Okay. And if I kept increasing this, if I kept increasing these values, instead of 10 million numbers, if I said, what if you have to sort more numbers? Right? If I said 50 million numbers, you would need to store approximately 200 MB is what is needed. Okay. If I said, how about sorting 1 billion numbers? Okay. Then you will need approximately 4 GB. And this will keep increasing. If you use an integer array, but if you use a bit array to store your values, which value is present, which value is not present, you'll only need about 4 GB of memory to store all the valid integers in C++. And this memory will not change. This memory usage will not change. It will remain constant. All that you will do is when a particular integer comes in, you indicate that it is present in memory. If it is not, if it doesn't come in, you indicate that it is not present, and so on and so forth. And you can store all the numbers that are present, and then you can effectively, represent all of your numbers that are available. Okay. So you can think of interesting ways of sorting or interesting ways of processing your data by altering the underlying data set. You can either get much better memory usage, you can get much better storage, you can get much better speed up and so on. So the kind of data set or data structure that you use underlying will matter quite a bit. Okay. But let us again not try to dwell too much on that. We've unfortunately spent way too much time on that question, about 10 minutes or so. So let's get back to the class. You think about this offline, okay? Think about why using a bit array, having this range is much better than defining a array with numbers. Okay. So think about why this is better as opposed to this. See, there are certain characteristics of pseudocode. Pseudocode represents the steps involved in an algorithm. It may or may not represent all the corner cases that are needed to be checked. Okay, so it may not check for all possible corner cases. So for example, in an industrial processing system, it may not consider this step. It may not have this step which says check that the raw material is not empty. So you will make an assumption that the raw material is available to you. Okay, and that the raw material is not empty. So it's possible that your particular pseudocode that you write or the process algorithm that you write may not check for corner cases. So you will check that the input data contains valid, check that the input array contains valid data. So for example, if you are asked to implement a sorting algorithm, you will make an assumption that sorting algorithm for digits, or rather integers, you will make an assumption that the input contains only integers and it doesn't contain anything else. Okay, it is human readable. It looks like a computer program, but it cannot be directly executed on a machine. Because when you want to run things on a machine, you have to check for these kinds of cases. You have to check that the input array is having valid data or not. So you'll have to check for these things. So it may not run on a machine. And obviously something that runs on a machine cannot be human readable. It would have some syntax and so on. It should accurately represent all the steps of an algorithm to get the results for an input data. Okay. Now, sometimes this and this are at loggerheads. So there may be situations where you need to list out all the corner cases because they are very, very important. So in order to accurately represent all the steps of an algorithm, sometimes it may be required for you to write all the corner cases in the pseudocode also. But it is not a hard and fast. It's something that each individual designer of the algorithm decides by themselves. It should allow you to completely understand the algorithm and infer the aspects like runtime complexity, memory usage, and so on. This is very important. There is currently no universal standard or syntax for writing the pseudocode. There's no particular syntax or standard for writing pseudocode. Example control structures, if then else, numerical loops, conditional loops. And we have seen examples of this. Set of steps that perform a specific task. These can be used or defined using functions or procedures. You can create processes, you can create functions, you can have variables within those functions and so on. So it's all mostly what human beings can reasonably understand. You have seen enough examples of pseudocode, so I'm not going to dig through these. There is also this example of pseudocode. There they also have added comments. Okay. Again, very straightforward and easy to understand. So I'm not going to go through this in a great amount of detail. Flowcharts. Flowcharts were interesting. They were invented in the early 20th century by John von Neumann. John von Neumann is also considered to be sort of the person who created the initial computer architecture. So most of the computer architecture that we look at these days is considered to be Neumann computer architecture. So he was a computer systems designer at IBM, and the early set of how a computer should be organized was set forth by John von Neumann, early theories. It represents logical elements in the form of geometric shapes. Control or the program flow is shown by using arrows. It is used in very large number of domains to represent either processes, control flow, or computer programs, and so on. The caveat is these are very easy to interpret if the algorithms are small, but if the flowcharts become very large, then it becomes a little difficult to understand because following all the arrows just becomes very tough. Okay. Now there are several flowchart standards and notations, but there's nothing universally adopted. There is no rules or regulation that are universally adapted. In the computing domain, certain conventions are accepted. Now, what are some of these conventions? Again, people don't always follow them. There are individuals who will choose not to do it like this. So program flow is represented by an arrow. But sometimes people may decide that they don't want to use arrows, they want to use something else. Or they don't want to use straight line arrows, they want to use curved arrows. So sometimes that may happen. Terminal indicates the beginning or the end of a function. A rectangle indicates a process, indicates a step inside an algorithm. Decision boxes are shown like this. Inputs and outputs are represented in this parallelogram fashion. Comments are written in this way. Predefined processes or other functions are written like this. Connectors are written like this. Databases, documents, multiple documents, any manual operation, manual input, and program initial conditions. Okay. But this is not hard and fast. Some people may follow a different, different technique of representing this, but more or less, this is what people stick to, at least in computer science. This is an example flowchart to show start and stop of robots. Okay, again, I'm not going to go through this in a lot of detail. It's a very straightforward algorithm, very straightforward set of steps. Decisions are represented by these decision boxes. Rectangles are used to represent steps. So for instance, here, this initialize step, ideally, according to the flowchart convention, it should have been written like this or like this. But they've just decided to use a rectangle. So there are no hard and fast rules and regulations to saying only this is the only way to do flowcharts. But if you join a particular organization, in that organization, there may be a standard and people may want you to stick to that standard. But it's not like there is a universal standard somewhere written in a ASCII standards document or something. These are again some simple flowcharts that I've written to show different methods to swap numbers. Flowchart to do processing of an automated boiler plant. So it doesn't mean that flowcharts are only for computer science. Even things like refineries may use flowcharts. Even raw material processing might use flowcharts. So all kinds of organizations might end up using flowcharts. Now let's get to finite state machines. These are a bit more interesting. And these are some things that, yeah, Eric, please go ahead.
Prof, just a quick question. If we somehow we face a question or you give us a question, do you prefer a particular standard in flowcharts? You as in this course.
In this course? You're asking me, do I prefer a particular standard in this course?
Yeah, our flowchart. Yeah, maybe you have.
Yeah, so you can stick to this. For the purposes of this course, just stick to this slide number 13.
Okay, thank you, Prof.
Okay. Yeah, so a finite state machine or a finite state automata, it is represented by the following system. It is represented by a set of states. Okay. And S0, which is a special set of states which indicate the start of a process. There are edges which allow you to transition between one state to another state. and SE, which is a set of special states which signify the end of a process. So S0 and SE will be part of S only. So S will contain S0 and SE as well, but sometimes they are written separately. The start states and the end states are written separately. Okay. So this is a simple finite state automaton, which is modeling a diesel generator. So this has 1, 2, 3, 4, and 5 states. Okay. And one of the state is the start state. So this is your start state and it is also the end state. So this is both the start state and the end state. These arrows represent transition from each state to another state. So is the engine generating power normally? Okay. So if the engine is generating power normally, then you go through this particular loop. Okay. When the engine is started and the engine is generating power normally, you keep circulating in this particular loop. But if the engine is not generating power normally, you get into this particular state, which could be a state where there is no oil in the generator or the generator is overheated. Okay. And because of this, you would go into a situation where the engine is generating low power, where the engine is generating low power or no power. Now from here, if a normal oil and normal temperature is restored, then ideally the engine should again go back to this particular state where the engine is generating power normally and it should continue to be in that state. Okay. So this is a simple state machine where you're saying if the engine is operating normally, it will continue to operate normally until this state comes up, where there is either no oil in the engine or the engine has overheated. And in this particular state, what may happen is you go into this state, which is engine is generating low power or no power. And the engine will continue to be in this state till normal oil or temperature is restored. Now from this state, if the engine is shut off, it can go into the end state. From this state, if the engine is shut off, it can go into the end state also. So it's a simple, very, very simple process, not at all complicated. You're just measuring oil and temperature to determine how this engine state can be changed. But there could be a lot more complicated states in the case of finite state machine. There can also be probabilities or yes, no conditions on these transitions. Okay, there could be conditions on the transitions and we'll look at that. So for example, this is a finite state machine to accept certain words in Hindi. Okay, now I'm not going to discuss this in a lot of detail. This can get very confusing. But look at this particular finite state automaton. Okay. Now this finite state automaton has a start state, which is this state. It has an end state, which is this state. And it is having all these arrows, which have certain alphabets on them. Okay. Now what this finite state automaton is representing is it is representing the condition under which you can accept different words. So can anyone tell me what is this also looking like? Like for example, when you're in state 0, there is no alphabet that is accepted. No word has been generated. This particular edge is saying, I will accept the letter F. Okay. I will accept the letter F. And this below this, it is saying F, right? This also means I will accept the letter F and I will emit the letter F. Go to state number 1. At state 1, I will accept the letter O, which means I'm accepting the alphabet O or emitting alphabet O. Go to state 2. At state 2, I will accept the letter X and emit X. Go to state 5. I will accept the end. So plus N indicates an end. And then I will, generate this particular symbol. And then I will terminate. Okay. Similarly, here I'm accepting the word cat. This particular loop, I'm accepting the word goose. Here I'm accepting the word geese. Now, what do you think this looks like? What do you think this looks like? This looks like a trie data structure, right? Except that this is actually used to model English words, and you can even use these to model generation of pronunciation. How do you generate the pronunciation for a particular English word? So you can use finite state automaton. So a trie data structure can be represented as a finite state automaton. Okay. Clear so far? This is another finite state automaton to represent, the traffic light system. Okay. When should a particular traffic light be red? When should a particular traffic light be green or yellow? Again, I'm not going to go through these details. This is not very necessary for us, but it's fairly straightforward to understand if you go through it. Okay, there are many states. So there are 6 states here. Okay, so the first the first state is this one where you begin, and it says the main road has green light, the side road has red light. Okay, the second state is main road has yellow light, side road has red light, and so on and so forth. Okay, main road has red light, side road has red light, and then main road has red light, side road then has green light. So only after both the roads are red can one of the roads state be changed. Okay, so it stays green in some time, then you get into main road being red, side road being changed to yellow. Then main road changes to red, side road changes to red in this particular state. Then you again get main road equal to green, side road equal to red, and so on and so forth. Okay, so this will be able to control maybe a 4-way junction, and how the different lights in that particular 4-way junction should work out. Okay, and these arrows indicate different time values. All right. So finite state machines are very efficient at representing the state of specific parts of a system. Very, very useful in visually representing and understanding how a system should work, how different parts of a system should get connected to each other. However, just because they are, you have to draw circles on a piece of paper and so on, connect them by arrows and all that, they can also become very large. And if you have very large finite state machines, how do you even print them on paper? So that might make it a little difficult, right? The difficulty only comes because if there are too many states, too many arrows, the arrows intersect each other. So it's not very clear which state are you going from and going to. So that might be an issue. The actual design and flow of an algorithm need not be represented by finite state machines. So you may represent the most important states of your system or the most important processes of an algorithm, and the remaining details could be hidden in pseudocode. Okay, so just to avoid finite state machines from becoming too big, occupying something that is larger than a big poster, people resort to actually reducing the number of steps that are shown in a finite state machine. Let's look at UMLs. UMLs are a little bit more standardized techniques. But again, even with UMLs, what started happening is people stopped following the standards. And everyone started designing their own ways of defining UMLs. But there is a particular standard that has been approved in 2005 for unified modeling language. So this is also a way by which you can visually represent how different processes and systems interact with each other. What are the different steps in a process? What are the protocols that one system sends data to another system, right? How does a particular set of processes send data to each other? If there is a state dependency, how to represent states in the system, system interactions, time-based systems. If there is anything that has to be triggered at a particular time in the future, how do you show that visually? There is a particular standard that has been implemented in 2005. Again, we are not going to go through these standards in a great amount of detail. But if some of you get into hardcore software engineering positions where you become a software designer, you may have to go through some of this. It combines the features of flowcharts, finite state machines, and certain other representation systems. Again, we will not discuss these in detail. We will discuss only one or two selected examples. And more details are useful if you particularly get into this domain. Okay. And there are online courses which you can take up, like there are professional courses on UML designs. But that's not strictly part of data structures and algorithms. Okay, that's why we are not using that. As long as you know how to write some amount of pseudocode and how to represent things in flowcharts, you should be safe as far as this course is concerned. We will never ask you to write a UML for a particular process or an algorithm. Okay. So different ways of representing, the process flow. One way is, this is an example of a diagram, or rather a sequence diagram, which is a type of UML. To how do you withdraw a certain amount from an ATM? Okay. So the way it works is, there is a customer object, there is an ATM object, there is an account object, and there is a checking account object. Okay. And there are various activities that this particular object can do. And there are ways of transitioning from one object to another object. So you are inserting an ATM card, you are getting into this particular process. And the ATM goes through this particular process. These details are not given here, but they may be written in a different UML diagram. They may be written in pseudocode. The ATM sends a request asking for a PIN number. The customer does something at his end or her end to get the PIN and enter the PIN. So essentially they remember, or they do whatever. They manually enter the PIN using that ATM's keypad, and then the ATM does something to store that PIN in an encrypted format, send it to the account to verify the PIN. If the PIN is accepted, then the request is accepted. What needs to be done has to be entered by the customer. Then this again goes back to the ATM. The ATM determines, okay, the user wants to do a withdrawal. It says, what is the amount that you want to withdraw? The user then enters the amount that has to be withdrawn. Then the ATM, after getting the amount that needs to be withdrawn, it sends that particular amount to the account. The account then checks and says, please withdraw the amount. The checking account will withdraw. Then the withdrawal is successful. Then it sends a confirmation to the ATM that the transaction is successful. So you dispose the cash, and so on and so forth. Okay. Clear? Yeah, go ahead, Emmanuel.
Yeah, so I was wondering, the methods like insert ATM card, request PIN, which entities or which objects do they belong to? Do they belong to the ATM or the customer in this case?
See, that kind of detail is not really important for us. Again, this is just an example that I've used. Does insert ATM card belong to the ATM object, or does it belong to the customer, and so on? I wouldn't suggest you should be really worried about those aspects. Okay. This is just an example that I've suggested. It may belong to the customer object, it may belong to the ATM object, or it belongs to both of them together. Okay.
Thank you.
Yeah. If you look at this, right, this is more in terms of a flowchart. Okay, this is the same thing, but written in terms of a flowchart. So this is called a sequence diagram, and this is called a state diagram. in the UML parlance, in the UML world. So this is another example of a unified modeling language use case, right? So let's say there is a particular vending machine and you want to represent what are the different activities that have to be done on that vending machine. Now, who are the different people who can interact with that particular vending machine? So by the way, this is called a use case diagram. What are all the use cases of a particular piece of equipment or a particular algorithm that you're implementing? So in this case, there is a vending machine, and what are the different use cases of the vending machine? The different things that can be done with a vending machine is fill the items, audit the items. That means count how many items were consumed in the last 1 week or 2 weeks or whatever. Repairing or moving that particular vending machine. Purchasing the items. Somebody wants to go to that particular machine, put some money in it and purchase, something from that particular vending machine. So who would typically do which of these steps? An owner of the vending machine may do all of these things. The owner might fill the items. The owner might do an audit. The owner may move or repair the vending machine. The owner, just to test the system, might also do some purchasing. They may actually put some coins in the vending machine and check whether it is working or not. A worker who is assigned to go and fix the vending machine and so on might only be doing filling of the items and moving or repair. There might be a contractor. So typically what happens is for various vending machines, there are contractors. So if a vending machine contains, let's say Pepsi, it also contains Coke, it also contains chips, and so on and so forth. Excuse me, I had to clear my throat for a little while. So that there might be different contractors assigned to different products. So there might be a contractor assigned to Pepsi. So this particular contractor will come and fill the Pepsi products, and that contractor will check how much of Pepsi products are getting consumed. So a contractor is supposed to only do filling of the items and auditing of the items. Customer is not supposed to do any filling, auditing, or moving or repairing. They are only supposed to come and do purchasing. So this is a simplified use case diagram for a vending machine. And there can be more interesting, more elaborate representations. Okay. This is a UML representation of how to accept valid comments in C++. And these are certain additional resources from which you can learn UMLs. Again, I will not suggest you to go through this until and unless you get a job where there is a requirement for you to design UMLs. Okay. It is not something that is extensively required in this course. I might ask you a couple of questions, like, I might show you a UML diagram and say, will this particular diagram accept a certain sequence of alphabets or not? So you might get questions like that, but I will never ask you to design UML diagrams. Okay. Or I might give you certain finite state automaton and tell you what are the alphabet sequences that are accepted by that finite state automaton. So with this, we sort of come to an end of this particular session also. And I'll see you on Wednesday, but I'll keep the class open for questions. We are almost out of time. So Venant, it is completely up to the organizer. So Venant is asking, do you design UMLs after writing the algorithms or flowcharts? See, this is totally up to your organization. They may decide to design a UML first and then write the code or write the algorithm. Typically, UMLs are written first. It very rarely happens that, there is already some code written and then you're generating UML for that. UMLs are first designed, so that everybody who is programming, say it's when you join large organizations, right? It is not possible that there is only one person writing the code. There may be 10, 15 people involved in the process. So who writes what, which person is responsible for which piece of code, who is going to write which test cases, and so on and so forth. All of that has to be made very clear. So you might use flowcharts, you might use state diagrams, you might use state pseudocode to indicate all of this. And UMLs are also a good way. So UMLs are also a very good way of saying this particular group of people will implement this code. This another group of people will implement this particular code, and so on and so forth. So in fact, you might actually say that everybody in a particular group will implement this piece of ATM code. Another group might be given this piece of ATM code, and so on and so forth. Any other questions? Any questions? If there are no questions, people can start dropping off. I will put a timer for a few minutes and I will stick on. But those who need to leave the class can go because we are already over time. Venant, do you have another question? Please go ahead.
Yeah, thank you, Professor. I have a question about the pseudocode. For example, when you have different if, like nested ifs, how do you know that such pseudocode doesn't belong to this block? Do we have do they use the iteration? How to know this pseudocode doesn't belong to this nested if? Thank you.
Yeah, somehow your voice is not coming very clearly. I'll try to repeat your question. Just tell me if I'm wrong. You're asking if there are some nested if conditions, how will you
Yes.
determine what is the pseudocode from which it is coming? Is that your question?
Yeah, that's my question.
Yeah, so that completely depends on how you write your pseudocode, right? So there is no clarity on how you will map it. So you will have to decide, or whatever organization you work for, or you yourself, let's say you're the coder, you write some pseudocode, then you should ideally have a comment in the pseudocode and also in your source code to say, okay, line number 20 to line number 35 implements this particular function in the pseudocode. Okay, this particular part of the pseudocode. So you will have to write comments like that so that people actually understand. So you'll have to make your comments much more explicit. And I've noticed none of the students have actually written any comments in their code whatsoever. So there are very few students who have written any kind of comments. Most of the students have not written any comments. So that's not a good approach. You should typically write comments. So for example, I'll try to show you what some students have written in the code. So let me just share. Yeah, students have written if conditions like this. So there are some students who have written if loops in the following fashion. Okay. I don't know what is going on in their minds. I mean, why don't you write an if condition like this? I mean, above is valid from C++ syntax, but it is a bad way to write code. Rather, or I think this should be and. I mean, you could have written it like this, right? Most of the students had, at least majority of the students had something like this. I mean, that's a bit ridiculous. It is valid C++ code. I'm not saying that the code will not compile. It will compile, but you don't write code like this. I had another Superman. I would call this Superman code. Equal to 1, 2, 3. Okay. And then that particular same individual had implemented this. Okay. Let's say this array contains some other numbers, 6, 7, 8. All right. These arrays were being used for different purposes. The only difference between them was capitalization. One was using letter A. See, the only difference between this was using small letter A here. This is using capital letter A here. I mean, this is also valid code. And another is using this is also valid code. So it will compile, it will work, everything will happen. I think this particular array, the student was using to store values that were present in array one time. And here they were using this for, I think this was boolean, if I'm not mistaken. So this was a boolean array that they were using. But anyway, the the type of array does not matter. Let's keep it as integer. So this was storing values that are duplicates. Okay. If you really want to do this, call it like this. I mean, give the array some name. Okay, so don't start giving, there are again some other people who's named arrays as in the same assignment. There were other, it's very difficult. It is very difficult to differentiate between data array and data array. I mean, people can make typos, people can use it in different places and so on. So don't create arrays like this. Similarly, there were people who defined arrays in this fashion. Same example. A1 and array A2. Why? Why are you doing this? Have some variables should have certain explicable names that can be understood. Okay. Anyway, we are 15 minutes over our time. So unless there are questions, we should end the class now. Yeah, Venant, please go ahead.
I was reading some pseudocode from the slide, class slide. I pasted it in the chat, in the slide number 33.
Slide number 33.
And I was wondering, the line 12 to 14 belongs to which block?
Slide number 33.
Yeah. The line 12 to 12 to 14 belongs to which block?
Which block of what?
You see, if else if all those lines belongs to that else if block.
Yeah, it belongs to the else part, not else if. The if part is this. So let me just copy this image and I will paste it here. Oops. What is happening to this? Okay, good. Where is this? Yeah, this is the one. No, this particular image you're saying. How can I take this image? Able to take graphics. Okay, see these lines, right? Line number 10 and 11. They belong to the else if part. Line number 12 and 13 and 14, they belong to the else part. Okay.
I was thinking because they are on the same indentation as the.
Yeah, it's very confusing. In fact, if you go through the pseudocode in the white book, right, lot of corner conditions are not mentioned. So to implement this as it is in pseudocode becomes little difficult. So in fact, when I was discussing red black trees with the TAs, they were saying, oh, this is very easy to implement. You're given the students a very easy task. But some of you may find it not so easy to implement.
Exactly.
See, if many students feel that, the assignments are too difficult, you're not getting sufficient time to work on them, I can even do the following. I can reduce one assignment completely. Or I can do things like I will select one out of the best, 5 out of the 6 assignments or something, but I don't want to do that. So what I can do is I can remove one assignment completely and increase the time that is assigned to all the assignments. But these kinds of requests have to come from all the students. They have to be directed to the TAs commonly. You have to talk to the TAs. TA should give me feedback saying that, look, Prof, most of the students have a difficulty in, being able to find the time to do the assignments. So why don't we reduce one assignment, or why don't we give them an extension and so on? So this is something that has to come from the student body as a bulk. So these are clearly mentioned. Otherwise, individual cases are clearly mentioned in the guidelines. Okay, but any kind of plagiarism is not going to be tolerated. You will get penalty. Unfortunately, many of the students in assignment number 1 are going to get only 50% of their credit, of their points. I feel bad about it, but that's what needs to be done. And when I say I feel bad about it, it's not that I feel bad not giving them points, but I feel bad that you have copied so much. I mean, why did so many students actually copy their code from each other? That is what I'm feeling bad about. Okay, so we are willing to help you out here, give you as much support in terms of, even if extra classes are required, we will do that. But a collective request has to come, and just merely going ahead and copying from each other will not work. So with this, I think we should really end the class. We are almost half an hour over time, almost, sorry, 20 minutes over time. Okay, any questions? Please come well prepared for the next few classes. We've finished a bulk of topics, so it's very likely that you may be tested for these. Okay, so please make sure that you come prepared. Okay, with this, I'm going to end the class now. See you all on Wednesday.